Day 7 is on the quadratic family and translations. Warm up. Let's say that the parent or the original function is y equals 4/3 x. How will y equals 4/3 parentheses x plus 2 minus 10 shift from the parent function? So if you recall what we've been studying, we've talked about how inside the parentheses, that's your left or right shift. So right here we have the plus 2, which means it shifts to the left 2. And then on the outside of the parentheses, we have the minus 10, and outside the parentheses, the plus or minus is up or down. So the minus 10 would be down 10 units. The 4/3 is part of the original function, if you notice, and so that doesn't factor into the up, down, left, or right shift. So just to review our summary, if we have some kind of function, y equals f of x as the parent function, then inside the parentheses is the x and the left or right shift. So right here, the minus h would move it to the right h units. The plus h would move it to the left h units. So again, the only thing inside the parentheses is the x and the left or right shift. And then our plus k is on the outside of the parentheses. And the plus k would be up k units, and the minus k would be down k units. So today we are going to introduce a new parent function, y equals x squared. So again, this is our parent or the original function for today. What shape is this graph? So if we didn't have a graphing calculator available to look at the shape of the graph, we could plug in to y equals x squared. So let's do that right now. Let's plug in a -2. So it'd be y equals parentheses or -2, and we're going to square that. And -2 times -2 is +4. And then we could type in or plug in -1 and square it. -1 times -1 is 1. If we square the 0, we get 0. If we square the 1, we get a 1. And if we square the 2, we get a 4. So if we graph this, let's take a look at what the shape would be. So we have -2, +4. There's our first coordinate. Then we go left 1, up 1. Then 0, 0, 1, 1, 2, 4. So here is our parent function today, x squared. It's called a quadratic. It's also called a parabola. So this is a quadratic. A quadratic is a function that has x squared as the highest power. A parabola means it's a U-shaped graph. So parabola, U-shaped. We can see it's symmetric. What that means is there's like a mirror image. Let's say my purple line, the y-axis right here, is a mirror. We can see that things are reflected across this mirror line right here. So we call that symmetric if you can fold it in half and it looks exactly the same. And so that mirror line is called the line of symmetry. And here the line of symmetry is y equals 0. Actually, no, it's x equals 0. Sorry, it's a vertical line. And the reason why it's an x equals line is because all along the purple line right there, it doesn't matter what the y value is. Any coordinate that I pick, the x value is 0 along that line. So that line of symmetry is an x equals line because it's vertical, and again, x is 0 all along that line. If we fold it over that line, that's like the mirror image, so we call it the line of symmetry. Let's talk about domain and range. Domain is all possible x values, and if you notice, we have arrows on each end, and the arrows will go all the way to the left and all the way to the right. It goes slowly, but it will hit every value of x, so we say our domain, our x values, is all real numbers. Our range does have a minimum value, so if you notice the minimum value, the lowest point in the graph is y equals 0, and then it's everything above that. So for our range, we say y is greater than or equal to 0. And then our vertex is where the graph changes direction. So let me write that down. It's where the graph changes direction. So what I mean by that is on the left-hand side, our graph is going down, but then all of a sudden at 0, 0, it changes direction and it starts going up. So this point right here, 0, 0, is the vertex. It's the lowest point in the graph if it's a U-shape. If we flip the graph upside down, it would be the highest point. So again, the vertex is where the graph changes direction. It's either the lowest or highest point in the graph. So there's a lot of information in this graph. Again, we know this is a quadratic, a parabola. A quadratic because x squared is the highest power, a parabola because it's a U-shaped graph. We know that the domain is all real numbers because our graph will go all the way to the left and all the way to the right. We know that the range is any y value greater than or equal to 0 because 0 is the lowest point in our graph and it's a closed dot. The vertex is where the graph changes direction at 0, 0. And then our line of symmetry is where you can fold it in half and it would be a mirror image of itself. And so that mirror line, since it's vertical, will be x equals 0 because all along that line the x value is 0. So today we're going to explore how to translate this graph, this parent function y equals x squared. So it says each graph below shows the graph of the parent function y equals x squared with the vertex at 0, 0. Find a quadratic equation that produces the congruent parabola graph with plotted points. Apply what you've learned about translations of our functions from the previous lesson. So in other words, use what you know about the up and down, left and right shift, and the parentheses to come up with equations for your shifted parabolas. Test your equations in your graphing calculator to see if you are correct. And instead of our graphing calculator, of course, we're going to use Desmos. So right now you should open desmos.com. Oh, and note the shifted function has dots. Okay, so let's go over an example of what this part of the investigation wants you to do. So again, the shifted function has dots. So our parent function, I'll just make it blue here. Here's our parent function, the one that we just drew. That's y equals x squared. There's your vertex at 0, 0. Let's come up with a graph of the shifted function. It looks like this graph just moves down, and it looks like it moves down 1, 2, 3, 4. So I'm going to guess that my equation will be x squared, and then down 4 is minus 4 outside the parentheses. So let's test it. So again, you make a prediction. It looks like it moves down 4. Let's test it. I go to desmos.com. I'm going to type in y equals x squared for my parent function. Oops, I did x2. I want squared, so I'll use the calculator function. All right, so there's my parent function. So let's type in my prediction, y equals, and I predict it went down 4 by doing x squared, and then a minus 4 on the outside of the parentheses. And you can see that this does match what we had right here. So down 4 is indeed a minus 4 on the outside of the parentheses. The vertex, remember the vertex was at 0, 0, but now the vertex, again, it shifted down 4, so it's going to be over 0, down 4. So let's write that down, 0, negative 4. Our line of symmetry didn't change. Our mirror line is still this line right here, x equals 0. It did not shift left or right. So line of symmetry is still x equals 0. All right, let's do just a few more. We'll do B and C, and then I'll have you guys pause the video, and there's several of you to try, and then we will summarize, hopefully, what you have found investigating these shifts of our x squared function. All right, so B right here, again, the shifted function is the one without the dots on it. So here's my shifted function. Vertex is at 0, 0. Line of symmetry is at x equals 0. And it looks like the one with the dots goes up 1. Write that down, up 1. All right, so our shifted function would be x squared, and up 1 would be plus 1. So again, let's test that. I'm just going to go ahead and shift this blue function right here. And then we can see, hey, that did look like it goes up 1. I should use my projector mode. Give me a minute. Okay, so we can see, again, to get projector mode, I just hit the wrench projector mode because it's darker, easier to see. And we can see that, yes, our red function was the parent function x squared. And yes, if we add 1, it does shift it up 1, just like our picture here. So the vertex of the shifted function, if we go up 1, will be 0 because we go over 0, but 1 because we go up 1. The line of symmetry, again, did not change because we did not go left or right. Whoops. We only went up or down. So when we only go up or down, our line of symmetry is still, if I could draw a straight line here, x equals 0. Okay, let's try C, and then I'll have you guys try D, E, and F. I'll put the answers too so you can check. All right, so again, our parent function is, I'll make it blue, where the vertex is at 0, 0. Now this one goes to the right, 2. And so my prediction is I knew a left or right shift. The only thing inside the parentheses is the x, or the left or right shift. I know that the left or right is the opposite of what I think, so it shouldn't be plus. It should be minus 2. And then the squared goes on the outside. So again, the only thing in the parentheses is the x. And the left or right shift, the square goes on the outside. It doesn't go up or down, so I'm not going to write anything on the outside of the parentheses. All right, so let's check our prediction. And I'll change the blue one. All right, so x parentheses, and I said minus 2. We got to square that on the outside, and then that was it. And if you notice, yes, our blue function does look like our picture where it's shifted to the right 2. And so the graph of the vertex of the shifted function now, I'm going to go to the right 2, but up 0. So 2, 0. Our line of symmetry changed here because it was at 0, but it shifted everything to the right 2. It shifted everything to the right 2. And so our new line of symmetry is x equals 2. All right, so right now I'd have you pause the video and I want you to try D, E, and F, make a prediction, use Desmos to graph it to check your answer, and then can you come up with the vertex line of symmetry? What patterns do you notice in our examples A through F? And if you are understanding the pattern, can you give me kind of the rule? And we're going to talk about that in a little bit. So again, pause right now, try D, E, and F, and then when you unpause it, I'll go over the answers to D, E, and F. All right, so for D, again, the parent function is the one that's has a vertex at 0, 0. And this one shifts to the left. 1, 2, 3, 4. Left 4. So I know that my shifted function, the only thing in the parentheses is the x in the left or right shift. And it's opposite of what I think, so left will be plus 4. Doesn't go up or down, so there it is. The vertex would be 0, negative 4. And the line of symmetry, again, that did shift left 4 as well. So our line of symmetry, again, an x equation because all along the line x, the x value is negative 4. Okay, 2 more and then we'll talk about patterns. So E has 2 shifts. So again, the parent function is our parabola here at 0, 0. And I know that this one goes left 2 and it goes up 2. Okay, so let's write the equation of the shifted function. We have y equals x, and if it's left, it goes inside the parentheses, opposite of what I think, so there's the plus 2. I do need the squared there to make it curve back up, and then the plus 2 on the outside would signify up 2. So here's my shifted function to tell someone to shift the parabola left 2, up 2. The vertex would be negative 2 because it goes to the left, but positive 2 because it goes up. So there's my vertex. My line of symmetry, since I went left 2, it's x equals negative 2. And one last one before we start talking about the patterns, hopefully you've noticed. Again, our original function, our parabola, y equals x squared, has a vertex at 0, 0. And again, this one has 2 shifts. This one goes to the right. 1, 2, 3, 4, right 4, down 2. Whoops, I used a different color. Okay, so right 4, let me put this up again, too many colors. All right, so right 4, down 2. So when you write the function, we'll write y equals x, and then to the right 4 is the opposite of what I think in the parentheses, so minus 4. Again, the only thing in the parentheses is the x in the left or right shift. We put our squared here because it's a parabola. But then our down 2 is a minus 2 outside the parentheses. So there's our shifted function. The vertex goes to the right 4, down 2, so positive 4, but down 2 is minus 2. In our line of symmetry, again, we go to the right 4. So there's our new line of symmetry at x equals 4. All right, so hopefully you've noticed some patterns here. Vertex form of a quadratic is y equals x minus h squared plus k. So let's talk about the shifts. Okay, so minus h is left, h units, plus h is right, h units. And then the k value on the outside, plus k is up, k units, minus k is down, k units. So just like the patterns that we've noticed in the previous sections of this chapter, the vertex, though, will be the opposite of the h value. So here, if my h value is +2, the vertex will be -2. Now, whatever's on the outside, that stays the same. And our line of symmetry, again, is the opposite of what's in the parentheses. So if the parentheses is +2, that means left 2. Our vertex will be -2, our line of symmetry -2. And that works for this one as well. So here our h value is -4, but that does mean to the right 4. So our vertex will be +4, as will our line of symmetry will be positive. So again, it's always the opposite of h when you're finding the vertex and the line of symmetry. So the vertex will be the opposite of h, the k value stays the same, and the line of symmetry will be the opposite of the h value. Okay, so again, there's the h value. It's the opposite because left and right is opposite of what's in the parentheses. All right, so let's use that to figure out how the following graph is shifted and what the vertex and line of symmetry is for the following graphs. So here's our first one. In the parentheses is the left to right shift opposite of what you think. So the +4 is to the right, no, to the left, again, opposite of what you think. Left 4, the -5 is down, down 5. The vertex, though, since it's to the left, will be -4, -5. The line of symmetry will be -4. So notice the h value is the opposite of what was in the parentheses. All right, let's try this one right here. The -1 inside the parentheses, again, opposite of what you think. So minus we think to the left, but it's really to the right. So this is right 1. The -7 is what you think, up or down. So this is down 7. The vertex will be the opposite of the x value. So if you go right 1, the vertex is 1, and then -7. The line of symmetry will be the, again, the opposite of this h value right here. So it's always x equals, because it's vertical, +1. All right, so there's kind of a summary of what you should have gone over today in the investigation. So if you take a look at your assignment, it's just, again, I try to draw on that shifted graph as your dashed graph. I didn't do a great job, but there's the original function at 0, 0. How do these graphs shift up, down, left, or right? Write the equation. Remember, if it's plus or if it's left or right, you put it in parentheses with the x. If it's up or down, you don't need the parentheses. It has you draw them. So it's the next 2 pages. So it looks like pages 37 and 38. Yeah. 37 to 38. All right, so do this for tomorrow and check your answers.